and welcome. Today we'll be talking about organic chemistry. More specifically, we'll be talking about cyclohexane's chair conformation and how to draw it. As an example, we'll be using Cis-4-methylcyclohexanol. Alright, let's begin drawing Cis-4-methylcyclohexanol. Step 1. Draw two slightly offset parallel lines like this. Notice that these lines are slightly tilted to one side. Step 2. Draw two more parallel lines like this. Now, connect the two remaining caps like this. Step 4. Add the axial bonds like this. Notice that these bonds point either straight up or straight down, depending on what corner they're on. If the corner points up, the axial bond points up. If the corner points down, the axial bond points down. Step 5 is to add your equatorial bonds. Notice that these bonds point slightly down if the axial bond points up, and slightly up if the axial bond points down. Step 6. Number your carbons. Notice that you can either go clockwise or counterclockwise. Here we went clockwise. Step 7. Add your carbons and groups to the correct carbon. Using nomenclature rules, we know the methyl group goes on carbon 4. OH group goes on carbon 1. This is a cis molecule, so we need both groups to be facing in the same direction. In this case, both hydroxy and methyl groups are facing up. Step 8. Let's draw the chair flip. Begin by drawing your first two parallel lines tilted the other way. For steps 9 through 10, connect your lines like this. Step 11. Add the axial bonds. Recall that axial bonds point either straight up or straight down, depending on what corner they're located on. Step 12. Add the equatorial bonds. Step 13. Number your carbons, but be careful. Since we're drawing the chair flip, we want to make sure we begin numbering our carbons one place back. So, in this example, we begin here. Step 14. Add your groups. Notice that all the axial bonds are now equatorial, and the equatorial bonds are now axial, but that the bonds that used to be up are still up, and the bonds that used to be down are still down. Notice that our groups remain on the same carbons, with the OH or hydroxyl group still on carbon 1, and the methyl group still on carbon 4. The molecule is still cis, so both groups are still pointing up, but the OH is now axial, and the methyl group is now equatorial. And there you have it. You have successfully drawn the two chair conformations of Cis-4-methylcyclohexanol. These are known as conformational isomers, and are due to the cyclohexane ring flipping. Well, we have made it to the end of the video. Thank you for watching it to the end. If you like this video, please remember to like, subscribe, hit the notification bell, and watch more Autodidact videos.